So welcome back to our fourth lesson on more in C++. Just as a reminder, the number of the lessons starts from 3, and now that I am looking in the slide, it's correct, but not on the video. Okay, that's a pity. I will not fix it. Anyway, so this is lesson number 4, and starting from today, so this is our fourth week together. So I guess it's time to start seeing more C++ code. So ideally, I try to go from the most basic stuff to intermediate level and then advanced. The idea behind this is I'm trying not to leave behind people who know a strong background in computer science, but I also don't want to leave behind people who has this background and really wants to know like cool stuff about C++. So that's it. This is the end of your race month. So this is the period where you should be trying to learn how to deal with the tools. And from now on, I will be trying to focus the lectures more on C++ concepts itself. And also, if we have the time, I will be doing a bunch of live coding stuff, so you can see that I also make mistakes while I'm coding. Anyway, so let's get started with the lesson. So before we start with functions, I want to show you a small example on how to deal with strings on C++, because this is something that we didn't do on the previous lesson, and we should at least comment about this. So sorry, C fans, but I think it's good in general to pick C to show that we can do better. So this is how you will copy a string. So let's say that you have a string that you copy this into the string. So this is a string you want to copy, and then in C you will do const chars, and then you will do array, but don't worry if you don't understand the syntax. We are not doing C in this course. And then you will create a destination. There are better ways to do this in C, but the thing is, I want to show you that you can actually do this and actually make some mistakes. So then you will print the source to show people what is on the string, and then you will call string copy. And by the way, I am using C++ here, but I am using all the C functions. So everything from C can be used in C++, and this is something that it's tricky to comment on this, but it's something that I don't really like, because this made C++ an even more difficult language to learn, because most of the time you will Google how to do something in C++, and people in Stack Overflow will just give you replies using C style code. So it's really hard to say that this is C++ code or C code when you see a source file. But anyway, I'm just trying to show you that you can use everything from C here, and that's actually, for you, it might be dangerous. So string copy is a function from C, and it's defined on the C string library. Anyway, you want to copy the string that is in source to the destination. So if you do this and then you try it, so let's leave it for the end. So you can actually try this on your computer, and you will see funky behaviors. And depending on the compiler you use, you will actually see core dumps. And also depending on which optimization you pick for this program. So this makes it really unsafe. And actually, let's do it. Okay. So I will show you just really quickly like why this is super dangerous. Okay, great. So this is the example, and I will just build it and run it, and then of course my text editor is already saying there are a lot of errors, but you can actually build this. So let's build this with GCC, no optimizations, so 0, and then let's try this. the first thing you see is like you see the source and this is working, then you will see the destination, and in this case apparently it's working, but then when you try to access the source, something is weird. And it's even more weird because this was declared as const, so something is really funky here. But then let's say that you move on your project and then you enable optimizations because you want to make it run faster, and then the same program with different optimizations is crashing because there is an overflow. And I leave you as homework to detect why is this an overflow, if you know what is an overflow, and then you can text me later on the Discord channel that if you found the error here. But the idea is that I want to show you like how unsafe this might be, because you might be developing a super huge code base and then you have this that is working, that is unsafe, and then you enable optimization and suddenly it's not working. This is super painful to debug. In this case we have 10 lines, so it's easy, but if you're working on big projects, you will suffer this kind of bugs. So C++ is a better C, and the idea is that we should try to do stuff easier to read and also safer. So that's why you should be using C++ strings while you code for this particular course. In this case, if you want to copy the string, that was the idea of the previous exercise, you only need to do this. Destinations equal to source. This will copy the string that is in source to destination. It's safe. You will have no issues while working with this kind of strings, and it's also easier to read. Of course, I will be doing code reviews for your homework, and if I find a C string style on your code, then the exercise considered like completely wrong. So make sure you use C++ stuff. I would love to have a compiler option where you cannot compile anything that is C, like pure C, like the const char star. But this is not possible due to compatibility reasons with C. So make sure you use C++ strings while you do your homeworks, right? And I hope you get some feeling of why this is intuition, why this is better. Then, okay, someone says that when you Google, you just need to add more C++. This is still tricky. So sadly, more C++ resources are spread over the web, and it's not really easy to find, and also the documentation is not the best one in the world. So for me, this is something that actually impacts a lot on the C++ community. So putting more C++ into your query will not fix anything. Actually, you will see a lot of more C++ replies that has nothing to do with more C++. Okay, so people who like definitions. A function in programming, it's a name section of a program that performs a specific task. In this sense, a function is a type of procedure or routine. Some programming languages make a distinction between a function, which always returns a value, and a procedure, that is also called subroutine, which performs some operation but does not return a value. So in this case, C++ does not make this distinction. So if your function does not return any value, it's still called a function. And then if you go to the book of the C++ author, you will see this definition that I also like. That is, the main way of getting something done in a C++ program is to call a function to do it. Defining a function is the way you specify how an operation is to be done. A function cannot be called unless it has been previously declared. And then this you should know because you did the build system exercise. A function declaration gives the name of the function, the type of the value returned, if any, so you can return no value, then you have this called subroutine, and the number and types of the arguments that must be supplied in a call. So remember, in C++, types are really important, and people who's used to program in C++ like me, whenever you go to Python, you suffer because you miss your types. Because in Python, nothing has a type, so it's just everything is names. And then it's hard to tell what's going on. So the idea behind function is that your code can be organized into functions. So homework number 2, you should not be using functions. I mean, you can use functions, but they are like really small C++ programs where you can do everything inside main. And the idea is you can organize your code much better if you use functions. And that's why we did on the first homework the build system exercise, where you were playing with a sort of library. Because whenever you start working with functions, you will need to split your translation units. So this is your .cpp files, and then you will need a build system. Otherwise, you will be stuck always using the main function for everything. Functions will create a scope. So this is something really important. Remember, I will be trying to highlight this every time we encounter this idea. So when you create a function, you will open curly braces, and this will create a scope. Or like that is called the scope of the function. Functions will only have singular return value. So this means that the return value should be of one type. I will show you an improvement that C++ did over the years for this. But basically, the idea is that you can only return one type. You cannot do like Python, that you can do this duck typing pattern that you can return an integer or a float or maybe a duck or whatever. In C++, we keep stuff simple and we only return one type. And then any number of input variables of any type, so you can feed into the function whatever type and number of variables you want. And then it's really important that functions should do only one thing and do it right. The name usually must show what the function does, and then there's this good style convention that you write the functions in camel case. Of course, so I have a way to check this on your homework, and I can enforce you to do it, but I am trying to be flexible on this term, and if you don't like camel case, then you just don't use it. Of course, I will try to use it because I'm more used to this style, but it's just a style, so don't get really frustrated. Okay, so let's be a doctor and see how is the C++ function anatomy. So basically, this is the pattern of how to declare a function. So you will have some optional attributes that we will not see on this lecture and not probably on the course. These attributes could be no discard, no except. So there are some optional attributes that you will see in like really professional code bases. We don't need this for this course, so don't worry. You will have always a return type. So let's highlight, this is a return type. In this case could be integer, string, vector, whatever, you name it. You will have the function name, that in this case is camel case, and then you will have the argument list. And lastly, when you open the scope of the function, this is what we call the body of the function. So whatever is inside here, we usually call it the body of the function. So this is where the computation happens, and always defines a new scope that is called the scope of the function. You can access outside world scopes. This means like different variables through input arguments. So if you need to do some computation in your function that needs something from the outside world, then you will need to pass this information through the argument list. And then this function body cannot add information about the implementation outside this scope. What is the meaning of this? You cannot put information like how you do the computation on the body of the function outside the scope of the function. So whatever you need to do on the function must be defined within this scope. This is the example, and then there are some comments in here. So basically this line here is not part of the body function, so might be anything. And this is where you define your function, and then this is the body of the function. Whatever is inside here is part of the scope of the function. And then again, whenever you reach the end of the scope, whatever is after that is not part of the body of the function. Then we go to the second part of the function, that is basically the return type. It will be any type. So there are actually two possibilities. One is to return one unique type. Could be integer, string, whatever, or void. When a function returns void, that means that it's a subroutine or procedure and basically does not return anything. And there are some rules. So if the function has a return type, like integer, it must return a value. Otherwise, the compiler will give you a warning. But in the case of the homeworks, you will have an error, and then your build will fail. And if returns void, must not return any value. So if you declare a function that you say this is void, and then you're returning an integer, then basically it's an error. So these are like some examples. For example, F1 will give you an error because you declare that you will, let's highlight this. So you are saying here that you will return an integer and you're not doing anything, so error. And in this case, this is void and you're not returning any object, so this is okay. Then F3, you are saying that return one. So this is not an error. Sorry, this is the other way around, actually. So the idea is that this is okay. So this is goes with this guy because you're saying you have an integer and then you're returning an integer, and this other guy must be an error because you say that it's void, but anyway you're trying to return any type, and you can do as many combinations as possible. So if you have a type, return a value. If you don't have, don't return a value. Otherwise, an error. There is something that it's called automatic return type deduction that this has been implemented in C++ 14. So this is something that usually people who doesn't use modern C++ feature are not aware of. So I'm trying to show you on the very first scene you get in contact with functions. So if you have a really ugly type, then in this case you don't need to know what it is, the meaning of this type, like this dictionary that is std map char blah 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 blah. So you have, this could be like as long as you want. In this case it's not that long, but it's ugly. Then this is redundant, and especially in this case it's really obvious that you have this type here. So you can actually rewrite this and say auto, and then auto will deduct the type of this getDictionary function at compile time. So this is something that it can improve your code readability. And then bad news is that you can only use one type. We said this many times. So you cannot do like Python's type that you have like a full function where you will return the name of the function and then the value. And then you can do this syntax here with the comma. So people who know some Python, or people who took Sensor State Estimation 1, you might be used to this type of syntax where you say, okay, these functions will give me the name of a value of some variable, and then I can access these two different types, right? But then, suddenly, good news, modern C++ is here to the rescue. So now we can write this and make it actually 20 times faster with a similar syntax. But this is starting from C++ 17. This is one of the reasons I moved the course from C++ 11 to 17. So you can actually start using these cool features and make your programs look better. So let's rewrite this Python code that you know for a fact that will be much faster. And then we will see, I think in next lecture, we will be seeing like this guy that is called tuple. For now, you don't care. So let's call a function foo that is the same in Python, and then you will return name of the variable and the value, and then you just call auto here. So this is like really easy to write, and then you can do the same as in Python. You just do auto and then you say name and value, and then you can do name has value. So the same example, if you're like doing this after the live stream, you can try the Python example, try the C++ example. You will see you see the same output with the same syntax almost. And of course, it's much faster. If you're not using C++ 17, then you cannot do this, but it's because this is something that is called structured binding. And yeah, just be aware that if you're using like all compilers, this is not available. So modern C++ to the rescue will help you. Then there is a huge warning here. This is really buggy. And I will show you one example. So in this case, we have a function that is called multiply by 10, and then it will receive as input parameter a number. And then what I'm going to do is I'm going to multiply this number by 10. So let's highlight what I'm saying here, and then I will just return this value, right? And then if you call this function, you will create a new integer variable, and then you will multiply by 10, so it's 100, and then you will try to print this, right? But then the problem is this one. Whenever you reach the scope of the function, then this function red ball is created, right? And then whenever you reach the end of the scope of the function, this red ball variable will be destroyed, so it's not accessible anymore. But the problem here is that you're actually returning a reference to this variable. So basically you're creating a variable and this function will give you a reference to this variable, but then when you end the scope of the function, this variable is not there anymore. So let's try to see what is. So this looks like legitimate code, C++ code, but you will see that it's actually not working. So let's examples, and then let's create a directory called local reference, and then slice. Not really. Okay, so the name of the file, I will copy just the example to try to fit the lecture in 1 hour. So it's called func return local. We have 2 examples here. And then okay, so let's open text editor here. And then, so on past editions of the course, I usually try to type all the code by myself, but then we cannot do it in 1 hour, so sorry. Anyway, so now we have this example here. Again, the text editor, and if you're using the same configuration I gave to you, I think it's big enough there. You will see some errors, but never mind. Let's pretend that we can't see these errors. So let's compile this example. So C++ and then func return local.cpp, and then let's call example 1. Okay, there is a warning. Don't worry. So the compiler is smart enough to tell you you're doing something really wrong. But then let's try to run this example. And then this is working. It shouldn't be working. Why is this working? CPP. Okay. I need to show you that this is not working, and it's probably do optimizations. Okay, great. So let's do it again. So let's compile this guy, but then let's enable optimizations because we want our code to run fast. And then let's clear the screen, and then please tell me that you're not working. Great. You run this example, and then the output should be 100, but then every time you run it, you have garbage, right? And this is because you are actually returning a reference to an object that is destroyed, so you're basically accessing garbage that is in the memory. But then I will show you something really funky. That is what happens if for some reason you just decide to, I don't know, say here red ball is red ball. Yes, I know. You're just debugging, and then you want to print the output here. And then let's try to run this example again. Then again the warning, but then when you run it, now it's working. And this is super funky, and as a homework, you can try to explain why this is working. But this is something that for me it's really important, so I will make a stop here. And I will tell you that part of the philosophy that I want to try to teach you is that the fact that something is working doesn't mean that it's right. And also it doesn't mean that it will work in 5 minutes or in 1 month. So I have seen this in the past, and by no means I will let you do this on the homeworks or on your final project. So you have a bug here that is really easy to detect because it's a really simple example. And actually the compiler is telling you that you're doing a mistake, and also the text editor, right? But never mind. Let's pretend that you omit all this information, and then when you're debugging, this is working, right? And then you run it and say, okay, this is working. And then you say, I don't need this debug information anymore. So you remove it, and then you compile it again. And then when you run it, it's not working, because the fact that it's working doesn't mean that it's correct. So what you will do, what people usually do, is just, let's keep the print message, because yeah, if you don't do this, it doesn't work. Then you compile it again, and now it's working. And then you say, okay, Nacho, you know what? If you remove the debug message, the program doesn't work. And please try to explain me why the debug message should impact a number. So it has nothing to do, it's not related, something else is wrong. So please, never do something like this. Never leave a print message just because if you don't do it, it doesn't work. So keep this in mind. Yes, it will be really funky if you do this type of programming, and it will be really hard for you to debug this information. So here's the example. Try it at your place, and you will see if you add this line here, it will work. Just remember to enable optimizations, otherwise you will not see also the error. So all these funky programs will only make your life miserable. But then you will say, okay, if I cannot return reference to local variables, how should I pass like a really big object? Let's say I am doing a local computation on the function, and then I want to give you a big object. If I do a copy, then it's going to be super slow, and you will be crying and saying, how do I do this? And I say, don't worry, the compiler got your back. So if you have a huge variable, the compiler will attempt to do something that is called return value optimization, and then it will do it for you. If you want more information, just go into the link that is on the slide, and you can find some examples there, right? So I hope I convince you that you will never should just do stuff because if you don't do it, it doesn't work. So you need to step back if you see these type of funky behaviors and make it work. Moving on. So local variables are also part of functions, and a local variable is initialized when the execution reaches its definition. So basically, whenever you reach this function f, the local variable will be initialized, and then that's basically it, right? Unless declared static, each invocation has its own copy, so this is important. We have a function f, and then we have two variables, var1 and var2, and then whenever we call for first time this function here, then var1 and var2 will be created, and then when we call it afterwards, then a new var1 and var2 will be created. So they are like different objects in memory. So, but this is unless this variable is declared static, right? But then you say, okay, I want something, for example, a variable like to have a counter, like how many times I call this function. And if you don't declare this static, every time you call the function, you will create a new counter, so it will always be 0. So how you can do this is using static variables. Remember, static and dynamic, whatever is called static means something that is happening at compile time, and dynamic is something that will happen at runtime. So basically, this will create a variable that will be allocated at compile time, and you do this by declaring static. And then at this point, so you declare the function, right? But you never call the function yet. But anyway, because this is static, if the variable counter has been already allocated and it's accessible, right? So this function, it's already there, even if you don't call the function. And then the first time you call it, then you have an increment here, so the counter will be equal to 1, and then you call the function again, and then the counter will be equal to 2. So this is easy to understand, but easy to misuse. So here is some example, but my recommendation is, if you are doing, unless it's like only a counter or something like this, I feel like people tend to use this static everywhere, because actually if you're using this, means that probably you have a error on your design. And my recommendation is avoid using it. And I put there a link. There is something that is called the static init order fiasco. There is a bug that is really hard to debug and to find. And I've struggled myself in the past with this. and I spent weeks hunting this bug. So of course, my recommendation is avoid this unless it's extremely necessary. So don't get excited with static variables. If you're using it, it's very likely that you have a design error on your program. So just don't get too in love with this. So any local variable will be destroyed. Sorry, so there is one question that is, what is the difference between counter plus plus and then plus plus counter? I will let you search for this, and it's really easy actually. It's like counter plus plus will increment the counter. So in this case will make no difference, but if you're like doing a for loop, counter plus plus will increment the counter after the execution of the loop, and if you do plus plus counter, you will do it before. So that's the only difference. No, not really funky. Any local variable will be destroyed when the execution exits the scope of the function, and that's why you should not return reference to these variables. And then the last thing of functions, of the body of the specification of a function, is the argument list. So this is how the function will interact with the external world, and also all the arguments will have a type and a name as well, and these arguments are also called parameters, so it's the same. And unless it's declared as reference, so unless some of the parameters are referenced, a copy of the actual argument is passed to the function. So there are like 4 examples here. You can have like one function, let's go over these guys, that has like the same type but 2 different arguments. In this case, this will hold a copy of the values. In this case, we will pass references, so f holds a reference to the original arguments, and f would possibly change the content of these 2 arguments. And then if you declare this as const reference, then f will hold a reference to these arguments but will not be able to change the thing. You will all get used to this when you start doing your exercises, right? So there are some examples in here. And then also with these arguments, you can add default arguments that can accept. So when you declare the function, you can say, okay, this particular argument will have a value, even if you don't give me the argument. So the pro is that you can simplify function calls. Like I know this argument should be always has some number, let's say, unless the user of the function gives me the number. But the const is that these are evaluated upon every call of the function, and then the values are actually hidden in the declaration. And of course can lead to unexpected behavior when overused. So again, this is easy to use, but it's really easy to misuse. And then the style of Google is only use them when readability gets much better, and my style is never use them. Again, I spent weeks of my life hunting bugs that was related to default arguments. When you hit like really large code bases, and then you have all these bad practices, then this will fire back at some point. At some point you will have a bug, and then you will have no idea because you have like a layer of 2000 function calls, and in some of these calls, one of the function, the guy who wrote it thought it was a good idea to have a default parameter, and it's not visible in implementation, and you don't have time to like look the implementation of 2000 functions. And then the fact that there is a default argument makes the program compile and run, so everything looks to be working, but there is a bug in there. So it's really hard to debug this type of bugs. So my recommendation is never use it. So an example here, try it at your home. Then let's pretend that you want to pass big objects to C++ functions. And then by default, in C++, objects are copied when passed into function. We say this before. And if objects are big, then the function might be slow, because every time you call the function, then you need to copy a big chunk of memory. And then how you do this, you will pass by reference. When you pass by reference, you are like sending a small object that is just a reference, and then we will see pointers at the end of the courses, but for now let's keep it simple. And it's going to be much faster because it's just a reference, not the huge object. But the thing is, we have a new problem now. So we have this function that is called do something, and then we're passing a string. Let's pretend that this string is something important for us, and then we don't really know if do something is actually changing the string, because when you pass by reference, you can actually change the huge string object, and then unless you know you see the implementation, you have no idea if your string is safe with this function. So what is the solution? Use const reference. This way, when you pass a const reference to this string, if the function should not change the string, then you are safe that the function will not do it. And even if you try to do it, the compiler will fail and say you are trying to change something that is supposed to be const. So make sure you use const references. Then here I put you a link to a benchmark where you can actually click on the link and play with it, and you will see that passing some like small objects by value, it's 5 times slower than just doing by reference. And this is like actually not a huge deal, but just adding 1 ampersand into your function declaration, but you should know like the idea of why you're doing that. It will make your program run 5 times faster. So make sure you do this. There is an example of what is the intuition behind this. I will show you the GIF. So basically, this is the intuition behind like the pass by reference and pass by value. So in this case, you have a function that is fill cup, and then when you pass by reference, you will give a reference to the cup here, and then whenever you fill the cup, the original cup is also being filled because it's the same object. But when you pass by value, you're basically copying this mark here, and then you're filling it locally, but the original object has no impact on that. So in case this helps, so there is a post on paintg.com, you can go and search for that. And then almost reaching the end of like what I want you to know about functions. There's something that whenever you call a function, stuff will happen on your program. I will not give you the details of what's going on underneath, but you need to know what whenever you call a function, there are some additional steps that the processor, like your computer, must do in order to call this function. So we can say that calls are expensive, but they're not that expensive. But they're somehow expensive. So if your function is rather small, you could actually help the compiler to optimize this for you. So you can use inline. Inline is just a hint to the compiler. This means by no means that you're actually telling the compiler to do something. It's just like, hey, compiler, you can actually optimize this. And the idea is that should attempt to generate code for a call instead of a function call. So instead of calling the function when you reach the call, just try to put code in there. But this is only feasible when you have a rather small function. Sometimes the compiler will do it anyways, right? And then again, so there is some example here. You can actually check this out. So I will be doing a tutorial on this web-based tool. But for now, let's keep it really simple. So actually, no, there is a even more weird example, this guy. So you can click on the slide, and then you will see this compiler explorer that I will give you a tutorial on this soon. But basically, in this case, we have the factorial function, and then we are calling 7 times the function, and then we want to return the value, right? And then if you go to the main function, so every time you call this function, you will have a call instruction like here, right? So you have 1 call, 2 calls, 7 calls. So this is computationally expensive, let's say. And because this function is rather small, you can actually do, instead of just doing a normal function, you can do, why I cannot write here? Consent. It's because of this. Yeah. I love this. Why aren't you working? Okay, compiler explorer. Huh. Piss me off really badly. Okay, let's try it again. I would recommend you to try this with your computer. Can I write here? No. Maybe it's because it's like read only. No idea. Anyway, compiler, explorer. Oh no, I cannot write. What's going on? That's why you should be using open source tools. Okay. Goes. Okay. Then let's use the toolchain we use. That is, where are you? Lang 10, and then what? So we still see all these calls here, but then now that I can type, I can just say inline this, and then whenever you turn optimizations, so you will see something magic. Dun, 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 dun. Oh, come on, do it. Right, and that's all your program. So your program will return a value that is 1748. And why is this happening? Because the compiler is inlining this function call with code, and then it's optimizing it with the values you gave. So in this case, you're replacing a whole computation, but just one number. So this is like one of the reasons you want to use C++, because at compile time, you can actually get really, really good results, and then it's gonna make your program run much faster. And then this is the last thing we will see about functions today. Make sure you check the compiler explorer example, so you will see like how well you can do with C++. And then let's attack C, and then let's show how people is still doing overloading. So in this case, let's pretend that you are working with the C program, and then you want to use the cosine function, but then you have different types, right? And then you have like and how you deal with this in C, then you will define different functions that actually inside the function, the implementation is the same. And then you will start giving like funky names, like cos for one, and for the case that you have double, the case for float, you will have like cos f, and then cos l for long double, and then you can go on with the list. So whenever you need the same function that actually does the same operation, you will need to like have a huge implementation with all the like copy pasted code and just changing the types, right? And then the worst part of this is that you need to use different names of the function. So if you want to, so this is the C example, you can try it at your place. But the thing with this is that whenever you call these functions, you need to know which type you're using, and then call cos f if you're using float and all this thing. And then if this type changes, then you need to also change the function call and pick the one that is proper. So it's quite a pain, right? And again, we have more C++ to the rescue, and we will do C++ overloading that actually you can use the same function, right? So the same name. So in this case, the function is called cost. In this case, cost, the same, and only changes the input parameters, right? And this way you can make your program more readable because you only need to call the function cosine here. So if you do this, you don't need to worry about which type you are passing into the function call, that is this guy, because double, float, everything will work, right? And this is how you should be tackling your homeworks if I ask you to provide different implementations, right? So basically the compiler will infer a function from the arguments. So you will define like, let's say 3 or 4 cosines for different arguments. And then we will see how to improve this even further when we do generics programming at the end of the course. So we can use templates and just do it once. For now, let's leave this aside. And then when the compiler will look into the arguments, and then will pick the right call for the overloading function, right? So there's another example here. So you can actually do this much better using the Mangle functions, but let's pretend you want to know the type of some types, and then you will create this function type of. The function is the same. So this is when you define a function, that is type of, then in this case we'll receive an integer as input parameter, and then we'll return the string that is the name of the type, right? And in this case you're overloading type of function with a new type that is a string, right? And then when you pass a string, you will print a string, and then when you pass an integer, you will print int, right? So this is something you can do. If you need to do this in C, then you need to write one function that is called type of integer, and then another function that is called type of string, and then blah 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 blah, right? With templates you will learn how to do this like really easily with 2 or 3 lines of code, and for all the types you might encounter in your program, right? So lastly, let's see some good C++ practices. We have 15 minutes left, so I will stop doing live coding because I'm slow apparently, so we can stick with the 1 hour rule. So good practices when writing functions in C++. So the idea is that you want to break up complicated computations into meaningful chunks and name them. So name is important because you can actually make your program more readable. And again, if you have one function that is called meaning of life, and then inside this function you do 5 or 6 different computations, then you will need to write comments and say, hello reader, this function will do 5 or 6 computations. First we'll do this and this and blah blah blah. And then you have a lot of unnecessary comments that you can actually avoid if you improve your design, and then you split the functionality of the function in these 6 different computations. And then you have computation 1, computation 2, and so on. So that's the idea behind functions. So try to keep the length of the function small. So basically the length of the code. Ideally, like a good measure is like if it doesn't fit on your screen, then it's probably too long. But this is just depends on the application. Avoid unnecessary comments. So please stop this paranoia of commenting on everything. So the code should speak by itself. And one function should achieve one task. This means that no funky behaviors behind. And if you can't pick a short name for the function, so if the name of your function, if you look into your implementation, you will see, okay, do computation and then return a value, but if la 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 do. So if the name is really, really long, then probably you need to split the functionality. And lastly, and watch out, avoid C style macros. And if you must use it, use ugly names like macro blah blah blah, and with a lot of capital letters, right? So it's very unlikely that you need to use C style macros, but just avoid them. And I will not show you like why you should avoid them. You can Google or check for the ISO CPP standard, but please just don't do it. So this is like a good function example. We haven't seen vector yet, but we will see when we work with containers on next class. But basically this function will create a vector of zeros, right? So the name itself says a lot. So we'll create a vector of zeros, and then the parameter is size. So okay, and then it will return a vector of integers. So without looking to the implementation, so if I do this, so we are looking into the implementation of the function, then you can actually guess what the function doing, right? It will create a vector, will fit it with zeros, and then it will give you the vector, right? So this is something that it's sort of good function. So this is a really bad example of stuff you should never do. So try to guess what is the function doing, and I will guarantee you that it's impossible. So this is a really funky function. So the name of the function is func. It means nothing. The name of the variables also, it's A or B. Means nothing to me. And the function does not have a single purpose. Why? Because if B, then it will do something, but then it will do other stuff. So there's like multiple purposes behind this function. So never do this. So this is really, really bad example of a function. This is another bad example. So we have a function, it's called create vector and print content. So the name is too long. This means that something else is wrong. So you're basically creating the same vector as the first example, but you're also, so the addition for this is that you're printing to the standard output the content of this vector. That in this case will be zeros. But then this is the unprint content, right? So if there is an unprint content, then this means that you can actually split functionality and then create vector and print vector. And then whenever you want to create the vector, you create it. And if you're in the mood of printing the vector, then you call the function, right? So this is a really bad idea, and this is a good idea. So names are smaller. This means that you can split functionality, right? And this is something that I expect not to see on your homeworks. Let's pretend that you hit this function. So you're using a library and there is this square number. You receive a number and then you will return, obviously, because the name is saying so, the square of this number, right? And then you call this function and then you receive a call. And then your aunt is in the phone and say, hey Nacho, what's going on? You say, I have no idea. I received a call from you. You say, what? And then you go and check the implementation, and then you see this. Ah, by the way, you need to call your aunt at this point, or otherwise the program will crash, blah, blah, blah. Of course, this means that there's another huge error on your design, right? And this also, it's a really bad example of how you implement functions, because you're basically hiding some details of the function that are not visible to the outside world, right? And of course, this has no relation to square a number, so this should not be in here, right? So keep in mind, in this case, it's going to be hard for you because you will always have the implementation and the declaration of the functions, but keep in mind that if you're like working in a huge project, you will most likely just want to try to see the declarations and not implementation, because looking into implementation takes a lot of time. But if someone like call your aunt just because inside implementation, then this is a bug you will most likely struggle, right? Then those are some guidelines for functions. Homework number 3 will be out hopefully today. And then of course, I will try to give you much more feedback while I do code reviews with these particular homeworks on functions. So those are some small guidelines. So before we end the lectures, I will just give you a quick overview of namespaces. So this is something you will be using as well on your homework. So namespaces are a way of avoiding name conflicts, and it will help you to group projects into logical modules. So let's pretend that you have the same name for the same function, but actually there are different implementations in there. So you can avoid like the conflict of the function by just putting it in different namespaces. So there's an example here. You can try it at your place. And there's another example here. Let's pretend that you're using the vector container from the C++ standard, but you don't like it, right? And then if you try to run this example, this will compile. And actually the idea is that you put this vector, like your vector, on a different namespace, right? You should always avoid using this instruction. So you will see this on the slides. I'm sorry, I'm going super fast, but I want to make it in 1 hour for you guys. So if you see this on the slide, it's not because it's wrong, it's because I need to save space on the slide. But you should never do this, and there are many reasons of this, of why. But here's one example. So let's pretend that you're using namespace standard, and inside this namespace there is a function that is called POW, that is std POW, that is defined on this header file. But let's pretend that you don't know this, and then you say, okay, I want to define a POW function. There is nothing wrong with this. But then when you try to run this function, you will have an error. You say, why an error? And if you try to compile this, you will see this error. So call of overload, blah, 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 blah. What's going on here is that you're basically clashing two functions because of the using namespace directive. So in this case, when you do this, you're basically accessing whatever is inside the namespace standard, right? And because at some point in your program that might not even be in this file, maybe it's another file that you include and blah, blah, blah. There is a function that is std POW. But in this case, when you do using namespace standard, then you remove this prefix and then it's just PO. And then you have your own function that is called PO. And then when the compiler tries to give the implementation for PO, it has no idea which one should I pick, the one you define or the one that is defined on CMAT. So this is really funky, and this is one of the many reasons you should never use using namespace standard. If you see on the slides, it's because I want to save some space. And how do you fix this? Just use whatever you need to use. Let's say, okay, I want to use cout and end line without the std prefix. Okay, just do using std cout and using std end line. And this, if you run it, it will not crash, because this PO, it's basically this PO here is the one that we define here, and it's not the one defined on CMAT library, right? Because it's not std PO. So if you run this, it will work and it's actually correct, right? So to wrap up namespaces, if you need more information, just go and check it out, the reference at the end of the slide. But ideally, use namespaces to avoid name conflicts. And the idea is that whenever you need to use something from the namespace, you have two options: or you use a prefix, in this case my namespace, and then you call the function, or you just do using my namespace and the function. So you using namespace, whatever. So please avoid doing this, otherwise you will struggle. And then if you do this on header files, it's a huge mistake that I will be looking into your homeworks, because everyone who includes this header file without even knowing will have the namespace you're using there on the translation unit. So this is really bad idea. And then whenever you want to somehow hide some constants from the outside world, you can use unnamed namespaces or nameless namespaces, and that this will prevent other parts of the program to access this variable. So you have a CPP file, and inside this file you want to have constant that only belong to the file. So one way of doing that, constant or also functions. So before you declare static, so that's the old style of doing stuff. But now you can just throw it into an unnamed namespace, so you can still access the constant without the namespace prefix, but it's also only visible to this particular file. Okay, and rushing. So the suggested video for this week is this 15 minutes made by GitLab on how to do agile project management. Actually, we will not be doing this. I have strong feelings against agile. I mean, not agile, but how people think agile works. But ideally, so the code reviews process will be made through issues and milestones in GitLab. So I think 15 minutes is a good overview of what's going on behind the scenes. And also, if it happens that after your degree, you end up working for companies, it's extremely likely that you will be using these concepts. So it's not something we teach, it's not something we will require you to understand, but given the fact that I will be using the tools, and then you need to also use the tool, it's a good idea to spend 15 minutes just to have a quick overview, right? But yeah, that's it. Nowadays, most of the robotics companies are turning, if they didn't do yet, into software companies, and this is like the way people manage projects. So yeah, if you learn some stuff about this, it will probably help you in the future, because it's what is going on in the industry. If you didn't understand something from this lecture, go check it out, the C++ book. There's much more information in there, although there's probably too deep for you at this moment. And also there is some reference here on functions and namespaces. So that's basically it. 1 hour. So sorry to rush, but I think we saw most of the stuff that I care about functions. Homework 3 will be out soon and will be about functions, so you will be writing a lot of function, hopefully. And then yeah, so remember, deadline for homework 1 is this Friday. then you should be doing homework 2. I only saw one submission on homework 2. Just make sure that you don't, so try to catch up, otherwise you will like have a pile of homeworks, and the level of the homework, so the difficulty will be increasing over time. So right now we are like on really easy homeworks. Make sure you don't lose track. Any questions, guys? Remember, try to try the examples on the slides. So the slides is already on eCampus and on the website. So get the slide, try to run the examples, try to understand what's going on. That's probably the only way of learning C++. If you just stick to this 1 hour, then you will most likely not learn. Okay, guys, so thank you for your attention. Yeah, any question you can also ping me on the Discord channel. Okay, see you next week, and thanks again.